begins. Chapter 6, Combustion and Flame.
Education is the key to success.
Topics to be covered are combustion, combustible and non-combustible substances, ignition temperature, inflammable substances, rapid combustion, spontaneous combustion, flame, fuel, ideal fuel,
Fuel efficiency, calorific value, the meaning of kilojoule and per kg, burning of fuels, global warming, acid rain, structure of flame.
What is combustion?
A chemical process in which a substance reacts with oxygen to give off heat and energy is called combustion. In many cases, light also is given out when the process takes place.
Combustible substances, that is, flammable or inflammable substances.
Some of the examples being fuel, solid and liquid and gas.
Non-combustible substances.
As the picture shows, sand and stones. These are substances that don't catch fire and hence called non-combustible substances. These also are interchangeably called as non-flammable substances.
Why does wrapping a blanket around a person when his or her clothes catch fire help?
That's because when oxygen supply is cut, and that's what the blankets help do that. In many cases, it's recommended that one uses a wet blanket. What is ignition temperature?
The lowest temperature at which an object catches fire or ignites is called its ignition temperature. Some of the objects with a very low ignition temperature are petrol, coal, diesel, kerosene, etc. How do we control fire?
So water essentially cools and there's vapor that surrounds the fire which helps cut the oxygen supply and that helps douse the fire.
Small fires. How do we control them?
You can use baking soda, depends on the type of fire, and if it's, for example, a fire not of electrical substances or oil and some flammable liquids, water will not work. So you would need some other things which you would see in the next slide. Wrapping a blanket, and if it's a limited area, you can put a big vessel on the affected area as well to cut the air supply. Of course, if you have it handy, use a fire extinguisher.
Why does water not work to extinguish fire other than wood and paper? This is because first substance oil. As water is heavier than oil, you can also see that and observe that as oil floats on top of water, water goes down as you pour it on oil and oil keeps burning above.
It has oxygen in it as well. I'm talking about water, of course. And electrical appliances, the water can conduct electricity and also harm the person who's dousing the fire. Fire extinguisher. It mainly has carbon dioxide. Carbon dioxide is heavier than oxygen. Hence, covers the fire like a blanket, cutting off oxygen supply, and it doesn't harm the electrical appliance nor the person who is trying to douse the fire. Here on the right is what we've got, a chart that tells us which type of fire extinguisher will help douse the fire from which source or which is the fuel of the fire. So when you're looking around or walking in your office, schools, malls, theaters, shopping areas, and if you know it's an electrical fire, you should remember this chart and select the appropriate fire extinguisher. For example, if it's a wood or a paper or textile based fire, It's a water-based extinguisher that would help. That's why you see a green tick. But at the same time, if it's a fire caused owing to electrical short circuits, electrical contacts, or flammable gases, obviously you need to use either a ABC powder one or a carbon dioxide one.
Types of combustion. First is rapid combustion. As its name suggests, it actually is quickly burning things like gas. There are also substances like phosphorus which burn at room temperature in air.
What is spontaneous combustion?
When an object suddenly explodes or starts burning into flames, for example, crackers, sometimes even spontaneous human combustion takes place. But how does spontaneous human combustion take place?
Oh, well, it's it's not about the human suddenly exploding or catching fire. It's clearly the fact that he or she's got certain fuel, let's say kerosene droplets, or certain diesel or certain high combustible chemicals on the clothes or some in some surrounding areas, and then it there has to be some igniting point, maybe a small match or a small light or additional heat, because of which the sudden burning of the human happens.
And this takes place very rarely, so don't worry so much.
Flame. For example, try lighting a candle, a diya, or even a gas burner. So, what's the color of the flame?
It's a mix of orange and yellow, sometimes even blue. But if you have lighted a stove's flame, you will see the colors are blue and yellowish on the top, that too only if you increase the flames. This indicates full combustion, and the lesser the soot, the higher the temperature.
So, the blue flame is the most effective one, is it?
Yes. So in this picture, you can see that since the gas is in low flame, there is less of yellowish and orangish color. But in this picture, you can see that there's lots of actually more than this picture, orangish and yellowish color on the top. And in this picture, where and of course a candle is lighted, there's less soot it seems in the candle. That's why it is a bit bluish below, you can see, and the other parts are yellowish and oranges even in this picture.
Let's look at structure of a flame. Here's a nice diagram which outlines the wax candle and its elements, especially parts of the flame, the one that is the least hot, the one that is the moderately hot one, and the hottest part. Obviously, you see a small halo like light blue colored halo around the flame, which tells you that there is complete combustion. Greater the blue color, greater the combustion. The middle part or the zone where it's yellowish in color, that's partial combustion. And the innermost part of the unburnt wax vapors, that's essentially black in color. And that's when you have certain people trying to show you some tricks when they kind of move their finger through the flame. It's essentially when they move it through the middle part of the flame. They don't move it through the hottest part.
Have you seen the silver color formed of an egg when you burn it, or have you seen the black color on any glass piece? If you light a candle and put it below a glass, a blackish circle is formed outside. It indicates the deposition of unburnt carbon particles present in the luminous zone of the flame.
Oh, that's interesting.
Why do goldsmiths use the outermost zone of the flame?
I'm sure you have guessed it by now, because that's the blue colored flame and that's the hottest one.
If you go back a bit, you can recall it. It indicates full combustion, as you have already learned. What is a fuel?
Any substance that causes heat and energy used for domestic or industrial purposes is fuel. Wood, charcoal, kerosene, petrol, diesel, these are examples of fuel. And what's a good fuel?
One that is readily available, it's cheap, does not leave undesired substances, burns at a moderate temperature in air, and one that produces a large amount of heat.
Interesting set of characteristics.
Yes. What is ideal fuel?
Some parts which we just had a look at. The examples being natural gas, LPG, CNG, and fuels that essentially fulfill all requirements of domestic or industrial uses.
What is fuel efficiency exactly?
Fuel efficiency is the amount of energy derived or based on the amount of fuel consumed is fuel efficiency. To check this, you have to check the calorific value, which can tell you the efficiency of the fuel. You'll soon see a table in the next slide.
Calorific value. The amount of heat energy produced on complete combustion of 1 kg of fuel is called its calorific value.
Here's the chart that we promised a minute ago. We've tried to cover fuels from ancient times like wood, coal, cow dung cake, to the recent ones like CNG, LPG, even hydrogen as a fuel. And you can see the calorific values as well.
So, cow dung cake 6,000 to 8,000, wood 17,000 to 22,000, coal 25,000 to 33,000, and so on.
Indeed. So if you want to drive a very heavy train, let's say on diesel or biogas or hydrogen, obviously you can do it, but you can't really drive an electric a train on cow dung cake fuel. Kilojoule.
It is actually a unit of measuring energy, and 1 kilojoule is equal to 0.2 calories, and 1 calorie is equal to 4.2 kilojoules. In this, you can see McDonald's French fries and their kilojoules. You can always pause the video to take a look at that.
So does burning of fuel leads to harmful products always?
Well, if it is a very good quality product, it might not, but most of the fuels do. Carbon fuels like wood, coal, petroleum, which release unburnt carbon particles, which are harmful and can cause asthma and can also be extremely unhealthy for already asthmatic people.
These fuels give carbon monoxide gas as well, which again is harmful, and especially if coal is burnt in a closed room, it produces this poisonous gas and it can quickly kill a person.
Continuation of the same slide is third point. Combustion releases carbon dioxide, which can make the earth more warm or hot, as it is the greenhouse effect, but this can lead to global warming, which won't be good at all, especially for the animals living in the frigid zones, as the ice will melt there, hence spoiling their lifestyles. Living in the coastal areas will also be quite a risky thing, as floods will come more often as ice will melt and start flowing.
Indeed, the entire ecosystem gets damaged. So you have seen a lot of pictures of global warming impacting the habitats of penguins and polar bears.
Yes.
Burning of coal and diesel gives sulfur dioxide gas, and when our vehicles start operating, they produce nitrogen oxides, which in turn are harmful, and they are also extremely suffocating and corrosive. Additionally, they also mix with fresh air and form acid rain. I'm sure you've heard of acid rain in some large cities, which can spoil the soil, make it less fertile, harm trees and plants, and damage our buildings as well.
Therefore, these materials are being replaced with CNG, which produces them in a very less quantity compared to these.
So it's a more greener fuel.
Yes. Please don't forget to like, subscribe, and ring the notifications bell so that you get all our uploads first.
Thank you.
You can always ask your doubts to us through the comments section. Thank you. See you in the next chapter.